Okay, if you look at this problem, this is almost the same problem as the one that we just discussed. The only difference is that you have to, वहाँ पे क्या था, you analyzed a belt for satisfactory and unsatisfactory operation. If you look over here, it says design a flat belt, right? So basically, you have to design a flat belt, drive to connect a horizontal shaft on 16 feet centers. So basically, you will have a pulley, okay, and the center to center distance between the two shafts or the two pulleys is going to be 16 feet. Okay. The velocity ratio is 2 point, the velocity ratio is 2.25 ratio 1. ठीक है जी, तो हमें velocity ratio उसने दी है. The angular speed of the shaft uh, driving the pulley is how much? That is 860 revolutions per minute. ठीक है जी, स्पीड भी आपको दिया हुआ है, and the nominal horsepower transmitted is 60 horsepower. And under very light shocks, very light shocks means you have to put some value for ks for that light shocks. In this case, सबसे पहले if you go for the solution, तो the things that are given to you, आपको h nominal दिया गया है which is 60. The revolutions of the driving pulley are given to you, which is 860, and the speed ratio is given to you. Your it says very light shocks. For light shocks, the service factor is 1.15, and the center to center to distance is given to you, which is 16 feet. ठीक है जी. Um, you can, put some design factor. These are the decisions that you are making over here. कि let's say कि आपका जो design factor है, let's say that is 1.05, but you can say 1.1 or any value that is above 1 would be a good design factor. Um, and once you design, a few systems with belt drives, you will know what is the appropriate design factor. The initial tension, जो आप कह रहे हैं FI, it says that is maintained with catenary. Now, what is catenary? Catenary ये है कि this belt has the weight of the belt, which is the self, weight of the belt. What is this belt going to do? This belt is going to exert some tension in here due to its weight. And this is what they say, that the initial tension जो is in this belt, that will be due to its own weight. ठीक है जी, we are not putting, right now more Fi by displacing the pulleys beyond 16 feet. ठीक है जी. So though there will be some initial tension now. Let's say we make this the decision that let's use the polyamide material, and from this geometry, since your d by d is given to you, basically that is the velocity ratio. So you can choose some reasonable d. ठीक है जी, looking at the table from the minimum pulley size, and let's say for this specific design, let's say that we choose from the table 16 inches. So since the velocity ratio is given to us, that velocity ratio is basically d by d equal to 2.25 हो जाएगा from this value of velocity ratio. So that implies कि हमारा D जो है that will be 2.25 times 16, and that will give us the capital D in the diameter of this pulley, which is D, and this one is a small d. ठीक है जी. The belt thickness, once you choose this, let's say if you want to use the polyamide A3 type belt, so you will know the thickness from the table. जहाँ तक width की बात है, the width is also not given to you, so you are going to choose this, or you are going to come up with a design कि how much should be this be. ठीक है जी. तो in this problem, all the parameters, when you work them out, you will work them out in terms of rather, or you can choose initially, you can choose some b. ठीक है जी. Somebody asked that why is the, the factor of, why did we recalculate the factor of safety, and that is indeed very prominent in this problem. Okay, in this problem, if we decide to use the polyamide A3, so you know gamma for that, you know F for that, you know the allowable tension for that, and you can find CP as in the previous problem, right? So you go ahead and find your HD, which is H nominal K, S, and D, and also find the torque to be transmitted. Yeah, the torque transmitted. Now go ahead and find your phi and the exponent of Fi. The procedure is the same. Find out your FC, right? लेकिन देखिए यहाँ पे if you look over here, how did we find the value of FIA? That is in terms of B, right? Because FIA is equal to B times the value in the table, which is FA, right? And then some corrections applied to that, which is CP times CV. इस तरह है ना, right? So the value of CV for this particular belt is 1, and CP from the table is 0.94. ठीक है जी. So it will be, and FA is 100, so 100 times CP is 0.94 times B. B अभी हमने कैलकुलेट नहीं किया, and that is why this will be equal to 0.994 times B. ठीक है जी. Now you can choose any B as you decided for the pulleys, लेकिन it is your choice. You can assign some value to this B at this point. But it is rather good if you go further and at the end, with all these forces या जो भी आप कैलकुलेट करें, फॉर एग्जांपल यहाँ पे भी FC में भी B का टर्म आ रहा है. ठीक है जी. तो सिमिलरली आपके F1A, F2 ये तो आपके कैलकुलेट हो गए, लेकिन F2 जब आप कैलकुलेट करते हैं तो यहाँ पे भी सिंस यू आर यूजिंग दिस द वैल्यू ऑफ FA ओवर हियर, तो आपके पास 94 B आ रहा है. सो ये इक्वेशंस आपके पास इन टर्म्स ऑफ B आ जाएंगे सारे, इवन योर FI इज इन टर्म्स ऑफ B. ठीक है जी. नाउ if you look at the friction developed यहाँ पे, तो what are we trying to do over here is कि हमने क्या किया, हम कहते हैं कि let's say कि टेबल में जो coefficient of friction की वैल्यू है that is 0.8, right? And this is the maximum that we can go. तो हमने क्या किया, जो when we check for the friction development, we will put the value of F as 0.8, and over here when we plug in the value of Fi, Fc, F2, तो यहाँ पे इनमें हमारे पास B का टर्म था ना, तो the only B is unknown now because we are going to assume that maximum friction is developed, which is the coefficient of friction of 0.8. तो यहाँ से हमने B, जब हम इस इक्वेशन में आए तो we calculated B and that is 8.4. ठीक है जी. Now you can go back and put the value of the B that you just calculated from this 17-7 into all your equations and you will find your Fi, F1, Fa and so on. ठीक है जी. लेकिन यहाँ पे एक बात है, the value that you just calculated, is this a standard value, right? If this is available with the manufacturer, you should go with it. ठीक है जी. And it will be at the verge of the maximum friction that can be developed by using that material. लेकिन अगर आप इस वैल्यू को ज्यादा करते हैं, फॉर एग्जाम्पल इंस्टेड ऑफ 8.4, this 8.4 might not be a standard size and it might not be available. So this is the minimum of B that you are going to use. समझ आ रही है बात की? This is the minimum width. So you can go for 9 inches, you can go for 10 inches if that is available and so on. ठीक है जी. तो this value 8.4 will develop only a friction of 0.8. लेकिन जब आप इस B को अब ज्यादा, if I take it 9, I don't need this value. This is the calculated value from the friction development will now be less than 0.8, which is good. ठीक है जी. तो जितना मैं width ज्यादा करता जाऊंगा, my factor of safety will increase. Now in this case, this 8.4 is not available in standard sizes. Therefore, it is decided to use 10 inches. Now with 10 inches B, go ahead and calculate your values of Fi instead of this आपका ये क्या हो जाए 86.7 times 10 minus 332. तो इससे आपकी वैल्यू आ जाएगी. If you go up a bit more, यहाँ पे आपके पास वैल्यू हो जाएगी 7.34 times 10. ठीक है जी. So 73.4. ठीक है जी. Pound force and so on. Go ahead and calculate all your values over here, and then with those values use this 17-7 equation and find out again what is your F dash equal to, and you will find out कि आपका F dash जो है that is less than 0.8 now because you have increased your width. So if you recalculate that, that is going to fall at 0.479. ठीक है जी. And I just told you that there will be dip or there is going to be catenary due to the weight of the belt. So how much is that dip? We can the belt is going to sag down. That's the key. आपने देखा हो तो the belt is going to sag down due to its own weight. And now how much is that dip? You can basically calculate this. You can calculate this dip with this formula. C square W over 96 Fi. So if you go ahead and calculate this dip in the belt is going to be 0.470. ठीक है जी. So the other type belt which we use for power transmission is a V belt. And I already told you that in V belt, well, there will be some angle, right? Which you will, make this V belt with. This parameter is A. Okay. Now, the other parameter is B, right? So your belt is going to look just like this. Right? So this is going to be your belt. And this belt goes into a groove on the pulley, right? As far as V belts are concerned, in V belts, they are manufactured and you will select from them when you design, right? So in V belts there are different sections, belt sections. For example, section A that will have a width A and thickness be equal to 11 divided by 11 by 32. The minimum sheave diameter, which is the pulley diameter, is going to be 3, and the horsepower that it can transmit is between the range of 1/4 of a horsepower to 10 horsepower. Similarly, there is section B, and section B will have these parameters C, D, E, and these are the different belt sections, right? Now, you can convert
जी
this,
सर
yes,
सर जी मिनिमम शीट डायमीटर क्या है शीट डायमीटर क्या है
sheave is pulley diameter, pulley, this is pulley,
ओके
okay? Now, you can also these standard belts you can the standard V belts that are available in these circumferences, the inside circumference A20 in A sections, these are the available ones, in B these are the available ones, and C, D, E, and so on, right? Now, how do we specify a V belt? The name of a V belt or the designation of a V belt is very standard. For example, if I say that I am using a V belt, right? So I'll just say that I'm using a B60 V belt. What does this mean? That it has section B, and these two digits represent the inside circumference with a 60 inches circumference. ठीक है जी, inside circumference. I can also convert the inside circumference into length, and how do I do that? I add a specific quantity to the inside. For example, I'm using a belt C70. So if I want to find out the length of the C70, I will add 2.9 to this, and my belt length is going to be 72.9 inches. Where did this 2.9 come from? Because for C belt it is 2.9. If I want to convert a B75 belt I have, so I want to find out its length, that will be equal to 75 plus 1.8, which is 76.8 inches. ठीक है जी, तो ये आपका लेंथ conversion. And then for V belt, the center to center distance, um, the equation 17-16b, इसी तरह LP, which is the pitch length, that can also be calculated with 17-16. These are the different standard V belts which we have. For example, A type belt hai, and the sheave pitch diameter is 2.6. Acha, what is pitch diameter? Okay, this is the diameter at which we will find the linear velocity, and that is, देखिए यहाँ पे groove होगा. So which diameter will you take for this? Um, if this is the belt, there is a certain, जैसे हमने गियर्स में pitch circle define किया था, so it's basically the diameter of that kind of circle. ठीक है जी, तो if this is your pulleys diameter, the pitch diameter, and these are the different sizes given over here at different speeds. ठीक है जी, सो आपको हॉर्स पावर रेटिंग दी गई है. फॉर एग्जांपल 100 फुट पर मिनट है, तो विद दिस शू इट विल ट्रांसमिट 0.47, विद दिस स्पीड 0.62, एंड सो ऑन. ठीक है जी, सो दिस टेबल explicitly gives you the exact horsepower that um, uh, um, a belt section would transmit at a certain speed. ठीक है जी, unlike the table that we just talked about. Now, जिस तरह यहाँ पे हमें the horsepower is given to us. For example, let's consider this value. Now, this value is the tabulated value, right? Or the value available in the table. Now, in my application, again, when the manufacturer give us this value, he does this at a certain speed, he does this at um, at certain conditions which are unlike the ones that we are going to apply this for. तो हम यहाँ पे इसको correct करेंगे and we will find the allowable horsepower. What is the allowable horsepower? That is equal to these two correction factors से हम इसको multiply करेंगे h tab को and we will get the corrected allowable horsepower. Now what is K1 and K2? That is the correction for the speed. देखिए ये angle of wrap, because he does experiments with 180. He takes the same size pulleys. Both are the same size pulleys. So his conditions are different than ours. We might not have this. We might have this kind of situation. ठीक है, तो therefore we correct these and multiply that by K1, and K2 is the length conversion factor. So therefore our allowable horsepower will be the one from the table multiplied by K1 and K2. And where do you get K1 and K2? These are also available in the table 17-13 and 17-14. ठीक है जी, the angle of wrap conversion, if you have the diameters of the pulleys, you can find it from this table. Belt length conversion factor, ठीक है जी, the K1 and K2 from there. अच्छा जी, when you are talking about a V belt, the difference in V belt is, देखिए, the pulley is going to look like this, right? And you will have the belt in here, the belt sitting in here. ठीक है जी, so देखिए, the thing is, in the case of round or flat belts, the only surface in contact with the belt was this surface. यहाँ पे this is also in contact with the groove, and this is also in contact with the pulley groove, right? So basically it is in contact with the pulley, and therefore there is friction over here and friction over here. So the coefficient, basically the friction is augmented by almost 3 times when you use the V belts. ठीक है जी, अगर आप इसको फ्लैट करें तो what will happen? This is going to be a pulley which is of this dimension, right? Rather than अगर आप इसको fold करें तो again it will give you the same effect, but the space occupied is less over here. So therefore, अच्छा जी, इसी तरह groove का जो coefficient of friction है, that is 0.1523. So remember this, you don't have to look it in the table. आपके V belt के लिए coefficient of friction is always 0.1523. ठीक है जी, तो you can use the rest of the equations for the design of V belts as already stated. Again, H design जो है, that is equal to Ks and D. H nominal is the nominal horsepower, Ks is the service factor, and you can get that from table 17-5 depending on the conditions. And D is the design factor, and design factor should be more than 1. You can also अच्छा जी, how do you see over here is, in case of flat belt or round belt you can change your width, but in this case you cannot change your width. ठीक है जी. Though you can change the section, it might be section A, B, C, D, and E, and these different sections have different range of horsepower. But sometimes you might have seen that we have multiple belts on a pulley, राइट. ये आपने देखा होगा कि मल्टीपल बेल्ट्स ऑन पुली हम डालते हैं. एंड व्हाट डू दीज मल्टीपल बेल्ट्स डू इज कि देयर हॉर्स पावर कैपेसिटी विल be more. If one belt can transmit 1 horsepower, um, theoretically speaking, two belts will transmit 2 horsepower, three belts will transmit 3 horsepowers, and so on, right? But therefore, since we cannot change B, you can decide that you can use more than one belt, right? And how do you see that? कि देखें, अगर आपके पास डिजाइन हॉर्स पावर कुछ है एंड अलाउेबल हॉर्स पावर इज समथिंग एल्स, so you can divide the design horsepower by allowable horsepower. For example, we have 10 over here, and your allowable horsepower is 5, so you should use two belts, right, in order to transmit that. Generally, not so. This will be the number of belts, and over here, if you look over here, it says that number of belts should be greater than or equal to greater than or equal to um, NB, HD over HA. Now, why greater than?